Kent's live stream will start in just a few minutes.
Kent Martz here from Explore Scientific. Today I'm going to teach you how to polar align your telescope using a broom. Why do you need to polar align? Well, with a telescope that has an equatorial mount, you have to get that equatorial axis lined up with the rotation of the Earth. And to do that, we're going to start with the tripod. We're going to decide which one of these legs is going to point north, and we're going to set the tripod down so that leg is pointed north. First thing I'm going to do is use a level to make sure my tripod is level. So if it's tipped one side or the other, that's going to cause your polar alignment to not be accurate. So we're going to use a level for that purpose. Then we're going to take a compass, and just to make sure that I've got it pointed north, I'm going to use the compass, line up, and go, yep, that looks like it's pointed north.
Why
so here's what I'm going to do now. And this is where the broom comes in. The broom becomes a measurement device, if you will. So I'm going to put the broom on the ground with the tip of it right against the north leg of the tripod.
It's nowhere to be found.
And I'm going to back away, and I'm going to use the compass. I'm going to close one eye, and I'm going to use the compass to make sure that the broom is lined up with north, right? And so I can tell I'm off just a little bit.
That one
so I'm going to move the tripod
in
just a little bit, and I'm going to turn the broom. And the broom is what I'm seeing that line with to line up.
No, Paul said.
So closing one eye.
Paul said he wanted to push the sun
Now
catcher.
my broom is lined up perfectly to magnetic north. Right here is we're going to talk about something called magnetic declination. The magnetic north is not true north. The difference between true north and magnetic north can be off by as much as 15 or 16 degrees if you live on the east coast or west coast of the United States. Around the world, it varies.
My expectation.
And you have to figure out what that is for where you live. Because if you point at magnetic north, you're not going to be pointing at true north. You could be off by 15 degrees. Your go-to will never be accurate. So for this system to work, you have to know what that offset is and be able to program that into your compass. We're going to provide a link to a website and a video that talks about that a whole lot more. Now, we're going to make sure that the tripod is not angled wrong. I'm going to use a small tape measure, and we're simply going to come down here and being careful not to move the broom, and I'm going to measure the distance from the tripod leg to the center of the broom. That is 470 centimeters. That way, it is 470, a little, I'm going to call that good. Actually, I'm going to move the tripod a couple of millimeters, just like that. So now, we know that we're lined up true north with that leg, and these two legs are the equal distance from right here. So it's not pushed that way or that way. So now that we have the tripod with a good alignment to north, we have to put the head on the mount. And that's going to entail this. We're going to be very careful when we do this because we don't want to move the tripod. We're going to put it on and simply screw on the polar head just like this. Remembering everything's going to the north. Now if you're in the southern hemisphere, you're going to do the same thing. You can do the exact same in the southern hemisphere. Because it's not polar, it's polar alignment, we just don't use the star Polaris, which we're not using here. This is really good if you can't see Polaris, or if it's daytime and you want to do some solar viewing with a solar safe filter. So the last step of this process is to check the scale of your altitude, right? So we live at 36 degrees north, and I am going to turn the altitude until it gets to 36 degrees north. I'm going to stop, and that's it. With this system, using a broom, a compass, and a tape measure, you can achieve a good, decent starting polar alignment. Personally, I've used this, and I've got an amazingly close polar alignment. There's ways that you can use to refine your polar alignment, specifically drift alignment, but it all starts with a good polar alignment. You can do this in the daytime. You can do this in the nighttime if you can't see Polaris. It works all the time. It's a good way to get started learning the process of polar alignment. Isn't that great? I hope you've enjoyed this video. For Explore Scientific, I'm Kent Martz. Get out there and start doing astronomy. And keep looking up.
Please welcome to the Explore Scientific stage, Mr. Ken Martz.
Facebook Live, we are running a little bit behind some technical difficulties. Today we're going to be talking about, this is warm up for our Amazon Live. We're going to be talking about the National Geographic Deluxe Adventure Set. Comes with a 50mm telescope, a pair of 4x30 binoculars, and a dandy little microscope right here. We'll talk about more, and some experiment sets, all sorts of cool things. We're also going to be talking about a metal detector, the blue carbon fiber wrapped CF400 telescope, as well as moon map and a solar filter system that'll fit any telescope you have. It's going to be an interesting show. We hope you can join us over there, and I hope you enjoyed my Kent's Magic Minute, which is really like 6 minutes, but hey, you know, it makes it better to call it Magic Minute. And we're going to be doing a few more of those in coming weeks, talking about some mathematical things and things like that. So look forward to seeing you over on Amazon Live here in about 5 minutes. You can go to Amazon Live and find us over there. I appreciate you joining us. I hope you have a great Monday and your week is fantastic. We'll be seeing you the rest of the week, so have a great one. Kent for Explore Scientific.